to my channel once again. This is Shatari. In today's topic, we'll be talking about the periodic table. So in our SS1, we are introduced to this topic known as the periodic table as the first 20 elements. We are told that this table is the arrangement of elements on a tabular form using the atomic number. So in SS1, we are told that we have 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. But in today's topic, we are going to go more elaborate. There's a group known as the transition metal that is introduced between group 2, this group 2, and group 3, which is this group we are talking about. So we are going to use the same methodology we are taught in SS1, but in this aspect, we will introduce a family known as transition metals in this periodic table. So, what is a periodic table? A periodic table is an arrangement of elements on a tabular forms. This is the major classification of elements in chemistry, and it tells us how elements behave in each of the group. So, we'll be talking about the major features. When you see a periodic table, what did you see? What did you say? We said the table is made up of a group and period. We said the vertical column is known as a group, while the horizontal line that come across this group, they are known as what? The period. So in today's topic, in SS1, we are told that we have 8 groups and 7 period. But in a more elaborate periodic table at this our level, we introduce what is known as transition metal that contain 10 blocks, which is the 10 column. If we should add 10 to 8, we are going to have 18 groups. 18 groups. That in this case, that is why we have 18 groups on this periodic table. We have group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11, 12, 13, 14, 15, 16, 17, 18. So if this transition metal is removed from this periodic table, we are going to add this group 3 and group 2 together to make it 8 group. But in this aspect, we are making use of this 18 electron rule, introducing a family known as transition metal between these two, between this block, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the transition metals we are talking about. So what are the features of a periodic table? A periodic table contains what is known as a group and as a period, as I've said. We say in this group, we have 18 groups. On this periodic table, we have 18 group and what? 7 period. A scientist known as Mendeleev gave us a major contribution to this arrangement of this element, and he classified elements according to their atomic masses. And he classified elements according to metal and non-metals. But he was able to predict some element that is not discovered those days in this period that fitted properly to these characteristics of these groups. So in this aspect, we say these elements, they are arranged. The modern periodic law now state that the properties of this element, they are in accordance to what? To the atomic number. The element that are arranged according to the atomic number. What we mean by atomic number? We define atomic number as the number of electron or proton. That is to say, if an element should occupy number 1, which is a hydrogen, hydrogen have atomic number 1, helium have atomic number 2, lithium have atomic number 3. To the first 20 elements, to calcium have atomic number what? 20. So in these electrons, they are the one that moves around the system. We are told that an atom contains 3 particles. We say 2 of them, they are found at the nucleus. We say 2 of them are found, which is the neutron and the proton. They are found at the nucleus. And we have the ones that move around the system in form of soldiers that move around. They revolve around these centers. This place they are found, they are known as shell or orbitals. We are told about all this in structure of an atom. We said the one that move around the system, they are known as electrons. So the number of electrons determine the group or period such element will be. So in this now, we can equally say that each of these 18 groups, we have 18 families. We have 18 families. Let's introduce this first family. For instance, let's introduce this first family, for instance, known as group 1. If you see the group 1, we have hydrogen, lithium, sodium, potassium, rubidium, calcium, and francium. For instance, now let's have the electronic configuration of the group 1 element. Like the hydrogen have only one electron, it's going to give 1. It has only one electron in the outermost shell. We say lithium that have 3, it's going to have 2, 2, 1 as the electronic configuration. In our SS1, we are told that this electronic configuration, we use the K, L, M, N shell. We said the maximum electron this K can take is 2. Here is 8. Here is 8. A is 8, using the 8 electron rule. That the maximum electron this K can take is going to take 2 electrons during electronic configuration. That is to say, hydrogen we have K1. We have only 1 electron in the K shell. We have the lithium. We say lithium, we have K, we take 1. The L, we take 1. So the 1 electron is found at the outermost shell. Let's use sodium. Sodium have 2, 8, 1. It has 1 electron as well. We have potassium that is 19, 2, 8, 8, 1. You can notice that all these elements, they have 8 electrons in their outermost shell. That is why they are placed in group 1. So in group 2, they use the electronic configuration as well. Let's use the first element, beryllium. Beryllium have atomic number 4. For it to have a electronic configuration, you're going to have 2, 2. We have magnesium. Magnesium is 12. Have 2, 8, 2. We have calcium. Calcium is 20. Calcium is 20. It has 2, 8, 8, 2. You can see all of they have 3 electrons in their 2 electrons in their outermost shell. That is why they are placed in group 2. In group 3 as well, they are placed in group 3 because they have 3 electrons in their outermost shell. That is how in group 4 they have 4 electrons, 5 they have 5 electrons, 6 they have 6 electrons, 7 they have 7 electrons, 8 they have 8 electrons in their outermost shell. So the number of electrons in the outermost shell determine the group they belong. So by so doing, the groups determine the chemical properties of such elements. They share the same chemical properties. They share the same chemical properties. And we also said that the other features of the periodic table is that a periodic table contains what is known as period. The period come across these tables. For instance, now, if you check this period, they share the same characteristics as well. They share the same physical properties because they have the same number of shells on each of them. Like this group 2 element that have lithium and beryllium. Lithium is 3 that have 2, 1. Beryllium that have 4, they have 2, 2. Since they have how many number? We have 1 share, 2 share, 1 share, 2 share. So the number of share of this element determine their period. That is to say, period 1, they have only 1 shell. Period 2, they have only 2 shell. That means they have 2 shell. 3, they have the electronic configuration. They contain 3 shell. Like for sodium now, for instance, the electronic configuration of sodium is 281. 281. So in this aspect, it has one of the share, the other share, and this share, 1, 2, 3 share. So the number of share of each of the elements determine their what? That period. You might see in your question that in the periodic table, the period determines the what? The number of shares those elements have. Why the group determine the what? The last share of this element is known as what? As a group. By so doing, we have, as I've said, let's recap, we have the features of a periodic table. It contains the group, the vertical column, and the period, the horizontal column. So in this aspect, we're going to talk about blocks in the element of these blocks in the periodic table. The blocks in the periodic table. The blocks in the periodic table. Blocks So the blocks in the periodic table, we have the S block, we have the P block, we have the D block, and the F block. The S block, they are known as S block because their electronic configuration falls in S block. We said the group 1 and group 2, they are known as what? As the S block. Group 1 and 2, they are known as S block, while the group 3 to 8, group 3 to 8 contain what is known as the P block. P block. Under this P block, here we're going to have the metals. We're going to have the metals. We're going to have the metalloids. And what? And the non-metals. And the non-metals. So this part of this group, the group 3, 4, 5, 6, 7, 8, we say this group contains what is known as the P blocks. It contains the metal, the non-metals, and the metalloids. The metalloids are those elements that behave as a metal and as well as non-metals. So you can see it on the periodic table. There are a form of step case in the periodic table that falls between boron, silicon, arsenic, tellurium, and astatine. They are known as what? Metalloids. They are known as metalloids. As you move down the periodic table, they are just like a form of step. So in this group, we say the D block, which is known as the transition metals, is this 10 block. This 10 block is known as a D block. They are known as a D block. While here, group 2 and group 1, they are known as S block. While this group 3 to 8, they are known as what? As a P block. In this aspect, this D block, they are known as a transition metals because they form as a bridge between this group 2 and group 3. So if I should remove this bridge from here now, I can close this periodic table to be 8 electron row. That we have 8 electron row in our SS1 we discussed. That in this case now we introduce this transition metal known as D block because why are they called transition metal? They form as a bridge between group 2 and group 3 in the periodic table. So we also have we say block D known as what? Transition metals. Transition metals. So we also talk about the F block. The F block, they are known as inner transition metals. They are found between this period 6 and period 7. These two periods, they are known as the F block element. They are known as inner transition metal, known as latinides, and the what? And the actinides. Latinides and actinides. So we can see that this periodic table is a form of family that indicates that these groups, they are arranged vertically on the periodic table. It determines the chemical properties of each element. For instance, if sodium can react with cold water, potassium should be able to react with cold water. So in group 2, they are placed in group 2 because they have 2 electrons in their outermost shell. You can see now that we have 2, 2, we have 2, 8, 2, we have 2, 8, 8, 2, 2, 8, 8, 2. That is how they are arranged on the periodic table. So in this aspect, we say the number of periods determine the shell. For those that have one shell, it's placed in period 1. The one that have shell 2, that is found in period 2. Those ones that have period 3, they are found in what? In shell 3. So that is to say that this periodic table tells us how this element behave. So like the group, like I've said, it determines the chemical properties, while the period determines the physical properties. So this brings us to the introduction of the periodic table. Please do well to subscribe to this channel. As we move on, we are going to move on to the families of each of these elements. We'll move to the trend on this periodic table, the characteristics. Then we'll be talking about the ionic radius. We're talking about electronegativity, electron affinity, electropositivity, and so on. We know the characteristics on the periodic table, whether they increase or decreases down the group or across the period. Thank you very much. Do well to subscribe to this channel. Thank you.